All right, so does SAT prep improve scores? How many of you have actually taken the SAT? Okay, yeah, I figured. Okay. A certain high school offered an after-school SAT prep class that students could volunteer to take. 44 students took the course and then took the SAT. The average SAT score for this group was 1220. The average SAT score for all the students who did not take the prep class was a 1050. So, is the situation described as an observational study or an experiment? Okay, so did we have a variable that we decided who was going to take the SAT prep class or not take the SAT prep class? We didn't decide, right? It just happened. So this is what we call an observational study. We observe things happening. Okay, so as the student, we're not forced to take the class. Okay, so an experiment is going to have a treatment. An observational study is going to have no treatment. Okay, so what that means is like we have an influence on it or not. Now, this doesn't mean that there's not variables that come with this. So on the next one, it says identify the explanatory variable and the response variable. So what was like the cause and effect, basically? So the explanatory variable is going to be whether or not they took the class. And then the response is going to be their SAT score. So again, cause and effect, basically. Yeah. Yes. You have to say, hey, this person is going to go to this group. Now, we could have set this up as an experiment. We could have said, hey, all these people in this room, y'all are going to be numbered off. All the odd numbers are going to go to SAT prep. All the evens are not. Let's see what your scores are. I'd be careful using those words though, because that's going to be when we start talking about experiments, those words are going to be used. Explanatory and response can be used interchangeably. No, you can use this for experiment as well. This is just what was the cause, what was the effect. Does that make sense? Okay, let's keep going into it and then I'll explain it when we get done. Okay. All right. Can you conclude that the prep class will cause a student's SAT score to increase? Why or why not? Why? Okay. So no. We also have the students who take the prep class. Might be just like highly motivated. So like if I'm prepping for a class or I'm like preparing for the actual test, probably going to do better because I'm highly motivated. I probably have better scores. There's probably an expectation of, hey, you've got to get this score in order to go to this college.
Like you're willing to put effort into getting a better grade, so you can do outside variables like the studying or just the purpose itself is.
Well, isn't that everyone who takes SAT prep scores, no matter if they're negative about the SAT prep, you're not on the score.
I've seen a lot of parents send their kids to SAT prep, and those kids really suck. at like grades and things like that, but their parents sent them to the prep thing and they did horribly on the test. But just because you're preparing doesn't mean that you're going to get a good score.
From the experiment that we had in this people beginning for this year, then you can actually do the correlation and causation, but right now we just correlate. We can't see.
We let people choose. We didn't influence. We didn't get the highly motivated and the not motivated kids to both take that class. So we can't make that conclusion. Yeah. Okay. So just like what Nova said, we need an experiment to show causation. All right, so we're going to identify as many other possible variables that you can that may explain why the SAT scores are higher for those who took the prep course than those who didn't. So we already talked about a couple of these. Motivation level. Some of these probably are college bound. I mean, why else would you take the SAT? Time after school. It's like, I don't know about you, but I can't take a prep course because I can't fit that time in, right? And then maybe number of AP classes. Exactly. Exactly. All right, so here's a cute little diagram. So whether or not they took a class, I can write, I promise. The motivation level and the SAT score. So we know that the motivation level probably influences the SAT score. The motivation level probably influences the fact they took the class or not. But we're not really sure about this because we didn't run it as an experiment. Now, these are like correlated. Like, so what David was saying, you probably took that class, you probably did better on the SAT. Otherwise, you're wasting your money, right? That would be terrible. So they're correlated, but not caused. And we can say that about observational studies. Okay. All right. So design an experiment that would allow us to determine if SAT prep causes an increase in SAT scores. We need to be as thorough as possible. The first thing that you always have to state when you write an experiment is that you're going to randomly select however many kids. Okay, so randomly select, let's say 100 juniors, because that's probably the year that people take SAT, to be a part of the experiment. Okay, so we have our who. Now we're going to randomly split group. So half take the course and half don't. We're going to do 1 month later. Take SAT. For all. And compare scores. Okay, so the way you always want to write these experiments is you want to state the who, the assignment, and the comparison. Another way to think about this when you're writing the experiment is like, you remember back in elementary school, the who, what, when, where, and why. That's kind of what we did here. They told us who, they told us what we're doing, right? We're comparing scores. When, 1 month. I don't really have a where because that doesn't really apply here. Well, and we could say that. We could say 100 juniors from Peachtree Ridge. That could be a thing. We could run an experiment. So how terrible would it be to be told, hey, you have to take an SAT prep course? It'd be horrible. All right, we okay on this? Okay, I do want to show you a kind of like flow chart way to see this. Okay, so if you can either fit this at the bottom or fit this on the next page. But we had the 100 juniors. And then we randomly assign them. And then we had group 1. Yep, it's the same thing. We're just putting this on a little flow chart. Okay, so we had 50 of group 1, 50 of group 2. Okay, and we had SAT prep. And then we had no prep. And then we compared scores. Yes, because nothing is happening to them. So these are what we call the treatments. They either received the SAT prep or they had no prep. Yep. I mean, I would assume, yeah. I think they would have to control for like, hey, you can't study, or hey, you can study. Yeah. It's not the best experiment because I feel like also like telling somebody that they can't prep for the SAT kind of like sets them up for failure. So that's not really good. And we're going to talk about like ethics of experiments. Like you can't force somebody to take a drug that's going to hurt them. Yeah, can't do that. Sorry. For all of you people who are going to go and be psych majors, yes, you cannot give bad things to people. Like if you know it's going to cause them harm, you cannot do that. Okay, so a couple of things that we have talked about. Okay, we had a cute little flow chart. It kind of looked like this. We're just using letters to kind of shorten this. So this is a little flow chart that we talked about. Okay, A was our explanatory variable. So our factor. Okay, B was our response variable. C is what we call our confounding. Ooh. Confounding variable. And this is going to be related to the explanatory and maybe influence the response. So looking back, talking about motivation level being our confounding variable. So motivation level would definitely influence our SAT score. And might be related to whether or not they take the SAT prep class. Okay, we also talked about observational study. And that was no treatment really imposed. Experimental is where we're going to have a treatment. And it shows causation. It's whatever changes are made from one group to like another. So like what is done to an experiment or not. So let's define that on our paper. Treatment. So what is done or not to our experimental units. So our experimental unit is who or what is being imposed on. Okay, so experimental units, who, what is imposed on. And with the treatment, this is going to talk about levels of the explanatory variable. So whether or not they took the prep class. Okay, the biggest mistake that people make is they call things an observational study instead of an experiment. So I want to get us a little bit of practice on that. So go ahead and try your check your understanding down at the bottom. Okay, it's asking you about observational study. It's asking you to identify the explanatory and the response variables. Okay, so go ahead and take a moment, try those questions. It shouldn't take you longer than about 5. All right, so on the first one, I got experiment. Yeah, okay. And the reason why is they randomly sample and randomly assign them to 2 different groups, right? So they were like Ben's house or Jerry's house. Okay, the next one is an observation. And the words that you're looking for there, they try to trip you up with the randomly selected part, but the fact that they just kind of observed those 100 people still makes it an observation because no treatment was exposed, okay, or imposed. Explanatory would be the number of books. The response is going to be academic success. Everybody get on those. All right, part C. Explain clearly why such a study cannot establish a cause and effect relationship. Suggest a variable that may be confounded with the number of books that the family have in their home. What did you come up with? Yep. If they what? Okay. So maybe people with more books tend to study more. Probably a true statement. Yep.
Books within the home actually belong to the students or their members of that. Books, areas like that.
That's fair. My parents have a ton of books. Have I read any of them? No, most of them are Dr. Seuss. Yep.
So content inside of the books, are they study material books or is it just like the different kids' works?
Okay, that's fair. Do I?
Yeah.
That's my parents' house. It's like they have this like massive bookshelf, and I'm like, all of these are Dr. Seuss. All of them. So that's great. Okay, good. All right, then flip the page. We're gonna talk about beards. Yay. Yay. So that's funny. All right. So what is wrong with these experiments? So Mr. Wilcox is trying out a new beard oil to make his beard grow faster for No Shave November. Hate No Shave November. Anyways, at the end of November, his beard is 3 inches longer. He concludes that since his beard grew 3 inches, the beard oil must work. So what's wrong with this experiment? Yes, David.
He didn't try it without.
Okay. He didn't try it without beard oil. I feel like he probably has in the past. They just didn't mention it.
Yeah, like, there's no proof that he recorded it, so he kind of just said, "Okay."
Right. He also only did this for a month. So, like, really, can we say that this actually works? Do you know that certain foods like actually help like hair growth and that kind of stuff? Yeah. So, like, maybe in the month of November, he ate more of those foods. We don't know, right? What could be done to improve this experiment? Okay, so measure 1 month without beard oil. And so this is what we're going to call a control group, but I feel like you already know that. Yay, bio classes. Okay, and then measure beard growth for several months. Replication is what we're going to call this. If you can repeat an experiment, that kind of enhances that cause and effect feel. Okay. All right, so the track coach decided to offer the track athletes 2 options for daily workouts: a rigorous strength building workout or a relaxed workout of mostly stretching. Wow. After 2 months, the athletes that chose the strength building workout were 11% faster, go figure, while the relaxed workout was only 3% faster. What is wrong with this experiment? Right, so the athletes got to choose. And not randomly assigned. So technically, is this an experiment or is it an observational study? Observational. Okay, so describe an appropriate method the coach could use to randomly assign the 2 workouts to the 120 athletes. Okay, so remember, we got to do the who, what, when, where, etc. Okay, so the first thing we need to mention is how are we going to group them? So we can number the athletes from 1 to 120 and then use a random number generator to generate 60 unique numbers between 1 and 120. And I'm going to write all this out for you. Yeah. Okay, so nope, we don't like that color. Number athletes 1 to 120. Random number generator to generate 60 unique numbers. athletes corresponding to the number. We'll do strength workout. And the rest get relaxed. Okay, so numbered them 1 to 120. We find 60 numbers. And then we assign them to the groups. Now, what is the benefit of using random assignment? Okay, so we can determine if the strength workout actually worked. Okay, we eliminate some of the bias, majority of it. On a recent test day, an AP Stats teacher wanted to determine if smart pills would improve grades. As students walked into class, they were randomly assigned a pill that said either smart pill or sugar pill on it. The test scores were significantly higher for the groups that took the smart pill. Okay, so what is wrong with this experiment? Do what? Yeah, it would be bad for me to be like, hey, here's a smart pill, but you can't take it, right? That would be wrong. Okay, so students knew which pill they took. Also giving children medicine that they don't consent to, like that's kind of weird. They make like a big stink about like teachers like giving candy that's not already pre-wrapped. Like if I brought in brownies, like I couldn't do that because it's not pre-wrapped. Yeah, it's weird. I don't know.
Brownies for you.
If I bought them from the store and did not open them prior to getting here, then it's okay.
Can't like have it, so I guess you're not interesting.
Mm-hmm. Right? Wild. We trust a factory over, you know, just the person who's in front of you.
So good for them.
I feel like nobody's gonna complain if I bring in brownies,
I would.
but you know,
Probably.
listen, I'm not the best baker. It's fine. All right. So what could be done to improve this experiment? No labels. Okay. So this is single blind. This is what we call single blind, but somebody just said it. Double blind is if the teacher doesn't know it. Okay. And if I give somebody a sugar pill, what is that called? Placebo.
Oh.
What is placebo?
Now, I will say the fact that it does say like sugar pill on it and the kids do know, really it's not a placebo. But this is kind of simulating that. No, but what's up? Yes, very much so.
No, in my heart, if I go outside, it's I could be arrested, but I know what happened.
I saw it. Got the data. Yeah. Yes, technically giving children medication to make them smarter probably would be unethical unless like their parents consented to it or they consented to it. Yeah. probably not the best idea. Those probably should avoid it. We'll talk about that a little bit later. All right. So, well-designed experiment. Well-designed experiment. All right. So you've got a comparison of 2 or more treatments. So normally this looks like one group being no treatment and the other group being the treatment. You need to make sure that there's a random assignment. Replication, it's got to be replicable. You can't just do it like one time. So more than one in each treatment group. Or replicating the actual experiment itself. And then the last part is control. Okay, so keep other variables constant. So along with my math degree, I've got a psych degree. And so with that being said, when you are an undergrad, you have to participate, or some schools do this. UGA made us participate in some of the experiments that the master's programs were doing. So I think I had to sign up for like 2 or 3 experiments in a semester. And one of them was literally like watching Big Bang Theory and like eating snack. Like it was to like see if Big Bang Theory had an association with the types of snacks that people ate. It was a weird experiment, but I got free food and I got to watch Big Bang Theory for like 30 minutes. Huh? They didn't tell me the result. So the problem with this is if you're in an experiment, they don't tell you. They don't tell you the results of anything. Like they don't tell you also like what they're studying until after you do the experiment. So I didn't know why I was in there. Like random food. It was awesome. Huh? Yeah, I was like, yeah, this doesn't sound too bad. I mean, like you see the description of the experiment, so like there was nothing weird, but then there was like another one that was like pictures associated with like social media or something like that. I stared at a screen for like 20 minutes. So those were always really fun because they were always like weird. I was like, why are you studying this? But okay. Yeah. All right. Random assignment. We talked about that. All right. So we label and then we randomize. That's where you talk about your random number generator. And then you're going to assign to groups. This is going to show causation. So how do you show causation? You label, randomize, and assign to groups. You already know about placebo, but the placebo effect is when a fake treatment works. It's like I took the sugar pill, but did they actually give me the smart pill? I'm actually smarter because I took pill. Yeah, that's it. I took pill. Yeah, he took pill. All right. Now, blinding is when students and or experimenters don't know about the treatment. So blinding is when students or experimenters don't know about treatment. And that was really hard because it's kind of like you've got to know who's taking it to watch for the effects. But if you know who's taking it, like if I had like a bowl of like pills handing them out to students, sorry, that sounds bad. And I knew which one was which or which one you were getting, I'd be like, you know, that SpongeBob face, you know, you like Krabby Patties, don't you, Squidward? Like that face. So then that would influence the entire thing. All right, let's take a moment. Let's do our check your understanding. A, B, C, D. On D, it says create an outline. So kind of like what we did with the little flow chart. Okay, so if it ever asks you to describe, then you can use a bunch of words. If it says create an outline, that's where you're doing the little flow chart. Okay, so go ahead and get started on that, and then we'll talk in just a second. Let's talk about it. All right, so group of researchers in Africa find a creative way to protect cattle from lion attacks. They painted eyes on the cow's rears. To determine if this treatment is effective, they randomly assign the cattle to one of the 3 treatments: eyes on the rears, cross marks on the rears, or nothing on the rear. After 4 years of roaming the plains, the cows with eyes saw no deaths. The cows with a cross suffered 4 deaths, and the cows no marks suffered 15 deaths. Explain why it's important to have a control group that didn't get any marks on the rears. Well, the control group provides a baseline, so it's something that we can compare it to. Now, suppose the researchers had 1,200 cows. Describe how to randomly assign the cows to treatment. So first, you're going to label the cows from 1 to 1,200. Then you're going to use a random number generator to get 400 numbers with no repeats. Assign to get eyes. And then repeat that process. There we go. Process to get crosses, and remaining cows get no marks. I still feel like this one's a little unethical because it's kind of like you're sending cattle to slaughter, but not really, but kind of. That's just me though. All right, so what is the purpose of randomly assigning treatments in this context? So we determine if treatments cause death to decrease.
Which one? Yeah.
Okay, the outlines aren't bad. You're definitely gonna have one of these probably on your exam. Yeah, I could see this being an FRQ question. So create an outline showing a completely randomized experiment. So we have the 1,200 cows. We've got group 1, group 2, group 3.
Not want to have like a control group, so we could get better.
There's a no mark group.
Oh.
Yeah, so we got 400 from group 1, 400 from group 2, 400 from group 3. And these get eyes, these get crosses, and then these get no marks. And then you're going to compare your deaths.